Good afternoon, ladies and gentlemen. Welcome to TechGig webinar, our endeavor to empower techies. We believe that sharing of knowledge is the key of enhancing our performances and for our growth as professionals. With this principle in mind, TechGig has initiated a series of webinars conducted by industry experts to give a crisp insight of various domains. Today's session is first in the cloud computing series, and topic for today is hands-on Windows, Azure, and building deploying end-to-end applications. Our guest speaker today is Mr. Sachin Prakash Sancheti, Principal Architect at Aditi Technologies. Sachin is a motivated achiever with around 12 years of experience in Microsoft technologies with 2+ years focused on Windows Azure. He has worked on a variety of Azure-related projects ranging from application portfolio assessment for application migration to Windows Azure to actual migration and re-engineering of applications to make them run on Windows Azure. Gentlemen, this presentation will continue for next 45 minutes and we will take your questions after the presentation. In the meanwhile, you can post your queries through the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Sachin.
Hi, thank you. Good afternoon, everybody. My name is Sachin, and I'm going to walk you through Windows Azure Series Part 1, getting started. I hope I'm audible all right, and I hope you are able to see my presentation, which is shared with the first slide, titled as Windows Azure Series Part 1, getting started. Okay. So I'll take 1 minute, and I hope we settle down, and once everything is all right, then I'll move on to 1 minute. Okay. So I move on. Agenda for today's session is beginning with you to introduce what is cloud. What are the different service delivery models available for cloud? Where does Windows Azure fit into these different service delivery models? What are the features, services available from Windows Azure Platform? Then we are going to look into some specifics of service level agreements, pricing, available specific to Windows Azure features, and then the real part. I'm going to walk you through an end-to-end application right from Visual Studio, first fresh new project, to deploy it to Windows Azure and see it run. That is the end-to-end process which we are going to see. In the process, I would also run you through a Development Emulator, which is local environment available for Windows Azure applications to run and debug or test it quickly on your local environment. And then we are going to run it on Windows Azure Platform as such. With this agenda setup, I'm going to just set up the context for cloud, and then we'll move on to Windows Azure. Moving to the slide, a very brief introduction, which we are going to talk about what is cloud. So there are a lot of definitions available for cloud, and people are actually defining it in different ways, but I just want to keep it very simple. Let us call it as a cloud on-demand, scalable, multi-tenant, self-service compute and storage resources. What does it mean is you have all these resources readily available and very scalable resources on demand whenever you need it, and you don't have to depend on anything else. You can actually self-service these resources. Rather than looking into the definition, I would like you to understand the problem which cloud is solving. Generally, if you see this graph, which I put onto this slide, on the left hand side, if you see the demand and the service provisioning, okay, generally the yellow bar, which is we need a service provisioning as per the demand. But in a normal Normal scenarios, if you see, we already have a capacity inbuilt. We do not have on-demand or scalable capacity readily available. So we first create the capacity, and then that capacity is actually provisioned to handle the demand which we have thought about. Your demand might vary. It is not very specific to capacity. Sometimes you are running out of your capacity, or sometimes you are underutilizing your capacity. But whereas if the cloud comes in a picture, what happens is you can actually get your provisioning or your capacity readily available on demand as per the demand which is required. Okay. So if you see the difference between the graph, the capacity is going around the demand. That is the problem which cloud solves. That is why it is so important to understand the cloud. I'm going to move on to the next slide, which talks about very specific thing like cloud workload patterns. So what are the workload patterns? Which there are very specific 4 patterns which we can just think about, which are very well fitted for the cloud deployment scenarios. The first one is on and off. There are a lot of applications, social applications or enterprise applications or some business applications which do not run for all the time. So there are very specific, for a specific time duration they run, like for example batch jobs. If you want to generate some reports, these reports, for example, they run weekly. So why do you want to provision your server and keep it running for all the time for 7 days? Instead, what you can do is you can make use of cloud and run your application or provision your resources only for the time for which you need it. Once a week, provision your servers and run your applications and put it down. You don't have to invest your money, don't have to invest your resources running it for that extra 6 days. That is the first pattern, workload pattern of cloud. Second is growing fast. Sometimes, if imagine you come out with some application which is as famous as Facebook, and you had provisioned your capacity for 10, 20 servers, right? You're just thinking 1,000 users, 10,000 users. But suddenly, if you see that there are millions of users, just because your site is so nice and exciting, millions of users are hitting your site. So how do you grow? If you go by the normal provisioning, you buy the server, procure it, deploy, install, all those kind of things, it is a time-consuming process. Whereas if you want to grow, you grow fast using cloud because it is as simple as some minutes job. Just add your instances, number of servers, and you have the ready resources. That was the second pattern which we talked about. Third one, another very interesting. Third and fourth are very similar, but if you look at the third one, unpredictable bursting, it is like the same example. You have an application, and suddenly there is, imagine a news application, online news. Suddenly there is some disaster happening, and a lot of people, millions of people actually visiting that site. So you are not able to predict that load, that bursting. That is unpredictable bursting. It is unexpected, unplanned peak in the demand. That is another pattern where you are not sure about it. You can make use of cloud, and on demand it actually increases the resources, and you are never down. Your site is never down. The fourth one and the last one is very interesting. I think most of us actually know about these predictable bustings. Like a very typical example, like Christmas. You have all the online shoppings in Christmas time, Diwali time in India. The bursting is actually going to increase. That is what the predictability. Like another example is IPL. If you have a site which is streaming a cricket match, so probably IPL or World Cup is going to be something which you can predict. In this time, it is going to increase the load. And you can have that kind of workload pattern address in cloud. So after looking at these cloud workload patterns, we'll move on to specific characteristics of cloud. There are a lot of characteristics of cloud, but here we're just going to look into some specifics. Dynamic computing infrastructure. What it means is you have the computing resources like your server, CPU, memory, everything available dynamically. I mean, you don't have to actually block it and keep it in some data center and then say whenever I need it, I'm going to use it. It's readily available for your usage. A rapid elasticity. If you want to increase your resources, it is rapidly available as well as an elastic. You can just stretch it quickly and make use of it. Third one is self-service. As we saw all these characteristics in the definition of the cloud, what we talked about. But I just wanted to reiterate the point. Self-service based usage model. It is like you ask for it and you go access and service yourself. That is the model which cloud computing is providing, one of the characteristics which cloud is providing. The last one, very interesting, consumption-based billing. So here, there is no upfront investment cost. We call it no capex, no capital investment upfront. That is the biggest problem, one of the biggest problems which cloud is going to solve. Today, if you want to, if you are creating a site and you expect 1 million users, probably you have to invest a lot of money in hardware, resources, electricity, data center, network, bandwidth, and everything. And then there is a capital expenditure which you are going to spend on that. And then you start developing a site and deploying it. But as the cloud comes in the picture, there is no capital investment happening. You don't have to buy any server as such. You don't have to actually pay upfront anything. Okay? It is pay as you go about. If you use a server for 1 month, you pay only for 1 month. Forget about 1 month, it is hourly. If I am using a server for 1 hour, I have to pay only for an hour. It is as good as utility billing which we do for our usage, electricity usage or telephone usage. So there are specific characteristics of cloud. After looking into the characteristics, I just want to touch base on the deployment of cloud. There are a few terms which you might be hearing about cloud. Community cloud, hybrid cloud, private cloud. So we'll quickly see what they are and what are the differences. So public cloud, it is a service provider actually is making resources available for application storage, and it is delivering to all the general public over the internet. If you want to access a public cloud, you just have to create your subscription. Like for example, Windows Azure is a public cloud. You buy the subscription. When you say you buy the subscription, you're saying that yes, this is my account and I want to use it. So depending on the usage, they are going to charge. That is a public cloud, which is readily available for general public. Community cloud is a slight difference of public. They are very restricted to a specific community. It could be managed by a specific owner in that community and organization, or it could be outsourced to a third party to manage that cloud. But it will be used by a specific group of organizations. For example, banks. If banks want to create their own cloud, they can actually create a cloud and they will call it community cloud, which is not available for access to anybody else, but all the members in the community. Hybrid cloud, it could be a composition of 2 or more clouds. You could have a private cloud, public cloud talking to each other, or a community cloud, or data center, local data center talking to public cloud. So it's kind of a hybrid cloud, we can call it. Private cloud, it is operated solely by the specific organization. Like for example, in Aditi, if we have a cloud, we are having a cloud internally for our applications, or the internal applications. So that is very specific to the people who are inside our organization. So they're using it. That is private cloud. So it is. It can be managed by some external vendor, or it can be managed by internal people itself. But it is used only for the private usage in that organization. So these are the different deployment. Before going deep into the service deliveries, the infrastructure as a service, platform as a service, I just want to quickly touch this and talk about the different scenarios which we can think about for cloud. We already saw the workload patterns, but here we're talking about some compute surge in case you have some seasonal applications where you suddenly need some compute intensive processes to run. That is one scenario. You have high transaction volumes, massive throughput you need, or you have cross-company boundaries. For example, you have multi-enterprise applications, federated applications, for example. Then you have multi-tenant. That is a very specific, nice usage of multi-tenant applications developed in cloud. We have been working on a lot of applications. We migrate a lot of our customers to make use of cloud and sell their application as multi-tenant application. Tenant isolation, customization. Then there are some edge cases, for example, social application, as we took some example of Facebook kind of application, or some specific departmental applications, which are like you want to just use it for some specific time. The specific application scenarios which we just thought about putting it here. Interesting part. So we'll see, about cloud. There are multiple service delivery models. We're going to compare it with the traditional IT and the multiple deliveries which we have, and then we'll see where exactly the Windows Azure fits in. So if you look at the leftmost column, the traditional IT, you manage all these 9 layers of your data set or your application environment. Right from networking to application, you have to manage everything. Networking, storage, servers, virtualization, operating system, middleware, runtime. So all this botheration of managing your all these 9 layers of your application is with your enterprise, with your whole company. In case of another model called infrastructure as a service, so here we get infrastructure layer as readily available as a cloud to be consumed. So here the 4 layers, networking, storage, servers, and virtualization, is provided by vendor. It is managed by vendor. What you manage here is operating system, middleware, runtime, data, and application. Like Amazon Cloud is a specific example of infrastructure as a service. If you look into PaaS, platform as a service, here the managed by vendor components are increasing. They're like networking to runtime. All these components are managed by vendor. What you have to focus? You have to focus only on your data and application. You don't worry about operating system. You don't worry about runtime or virtualization system. You're not even bothered about operating system as such. The another last service delivery model is SaaS, software as a service. Here, the software is served directly as a service. You don't manage anything. You just consume the software. Like Salesforce.com is one of the examples. We'll see the examples in the next slide. If you look into this continuum, here, if you towards left as you go, okay, you have to manage more components. So it means higher in the cost, less agility. So you are not agile here. But if you go towards right, agility is increasing and the cost is decreasing because you don't have to manage, you have to manage less components. That's why the cost is low. That's Windows Azure Platform. This platform as a service. I hope we are clear about the infrastructure as a service, platform as a service, and software as a service concept, and why it differs and where exactly Windows Azure Platform fits. Having said that, we move to a specific slide where we are going to talk about some examples of infrastructure as a service. So basically here we have seen what column of infrastructure service. The on-demand servers they are providing us virtualization readily available. So example of Amazon EC2, VMware, vCloud. There are a few examples of infrastructure as a service. Platform as a service, we say that we just have to manage our application and data. In that cases, we have few examples like Google App Engine, Salesforce.com. So they have Host.com as such. We call it platform as a service, and Windows Azure. That is what we are interested in as of now. Software as a service, readily on-demand, readily available application. You don't manage anything. You just have to consume that. So like few examples, Office 365, SharePoint Online, Salesforce, Microsoft Office, company. You might be hearing a lot of these terms, service, platform service, and software service. I hope that clarifies that those names and the definitions. Now, what is the Windows Azure Platform? Having seen that it is a platform as a service. So let us quickly define it. I mean, definitions are we are free to make our own definition. So here we call it basically some of the people call it Microsoft Cloud Operating System, Windows Azure. But here some of the definitions are picked up. Windows Azure is a cloud computing platform developed by Microsoft that can be used to build and host online web applications through Microsoft data center. Very specific point. Microsoft has developed a huge data center and they are just giving us readily available as a public cloud to the end user. Anybody can subscribe and start using it. Management of the scalable web applications is also performed at Microsoft data center. In terms of automatic patching, the operating systems, antivirus, all high availability components, load balancing, all these things are being taken care within the Microsoft data center. You don't have to worry about it. You just have to use configuration. You just have to tell Microsoft, I need 3 instances, load balance in this region, that storage. All these things, you just instruct to the data center and everything will be readily available. Since we talked about Windows Azure as being a platform as a service, remember a very important point with respect to the platform as a service model. The real value of platform as a service is to have as many readily available, robust, scalable building blocks as possible for consumption and just making it simpler to plug it into applications to be developed. The reason I put it here is, if you want to compare few of the readily available platform as a service models or vendors, this is the line which will help you to, this is the definition which will help you to drop down or to finalize a specific vendor. Vendor platform as a service should have maximum number of readily available building blocks, so that as a platform, so that when you develop an application, you just have to plug these components together and develop your application quickly and so as robust, because the components which developer is vendor is providing are being tested and they are readily scalable and robust, fitting into the platform as a service model or in the cloud very easily. These are the specific platform features which I just want to touch base as of now. Since it is a first session in this series, I just want to touch base on the few concepts, and then later on in the next sessions in this series, we'll go into specifics, details, with some examples in that. So compute, where you have your web applications or worker roles. They call it web role, worker role. So web role means web applications. Worker role is some process which is continuously running in cloud. It is as close as Windows service. Then you have storage. So you have a storage like persistent durable storage. There are multiple types available in Windows Azure. You'll see that. Databases, you have SQL Azure as a relational database available in Windows Azure. So these are the platform features. So they are readily available building blocks which can be used to quickly develop your application. Virtual machines. You can create a virtual machine and just run it, deploy it on Azure and keep running. You don't have to have any infrastructure for running that virtual machines on cloud. Content delivery network, it is used for caching purpose. It delivers high bandwidth content through multiple nodes which are available across the world. I call it edge nodes. Caching, in-memory distributed application cache, where since we're talking about scale, cloud, we need some caching mechanism which is in-memory and very fast and distributed across multiple applications, across multiple instances. That is Azure App Cache. Virtual network, very interesting feature. Here, you can have your application, your local machine within your enterprise, and a cloud within the same network. So there is something called as Azure Connect, another feature which you can make use, and you can connect your on-premise and cloud applications using as if they are in a virtual network. Service bus is another interesting feature. It is used for messaging capabilities for distributed and hybrid applications. If you want to run a service on cloud, but you want to execute the actual execution of the service on-premise, there is something called as service bus for that. Access control, very much standard-based service for identity and access control. Very common problem for all the applications. Why should we invest our time and energy in developing all this authentication, authorization, all those kind of components again and again and again? So there is a building block readily available on Windows Azure platform called as access control. You can make use of it, and it also helps you to create a federated authentication models, single sign-on across your data center and cloud. Business intelligence, SQL Azure reporting services and new extra features that is adding into the Windows Azure platform. Marketplace, this is for kind of, as the name indicates, where you can sell by readily available applications or application building blocks or data sets in the Windows Azure platform. Remember, these are the existing features as of now. So it's very easy to deliver new features in cloud environment. If Microsoft thinks about adding something like this stock in cloud, so they just have to provide that as a service. If it's available, you can just make use of it into your application. It's just available. You don't have to change a lot of things. That is the best part of cloud. Similar features, I'm trying to map it here so that we understand what feature sits where does it fit. So if you look at these layers, so networking is somewhere, at the networking layer, we have Azure Connect, which helps you to create the virtual network within your enterprise, between your enterprise and VM, or virtual machines running in cloud. Storage, it is to store your contents. So there are 5 features available from Windows Azure. Table storage, remember it is not a relational database, whereas it is a table storage. Flat storage available. Blob storage, binary large objects to store your media, contents, files, etc. Queue, as we saw, asynchronous communication. Drive, There's something called as Windows Azure Drive, where you can have, it is actually nothing but an extension of blob, where you can create a virtual drive. You can consume it as if you are using a drive on your local application, like a D colon, wherever you want to create raw files, etc. And just make use of this drive. Content delivery network, as we saw, it is readily available kind of cache across the globe. Microsoft has put a lot of physical servers, and your cache contents will be delivered from that edge server rather than actually coming to your position server. In compute, so compute means the actual processing, the usage of the CPU cycles. So web role, where you have to deploy an application which is running on IIS, that is a web role. Worker role is very much like you have a Windows service kind of application which is running all the time. Mostly worker role has a specific task, or it is actually getting some messages from a queue and processing on that queue message. That is worker role. VM role, it is not launched as of now. It is CTP, I think. So virtual machine, you create a virtual machine and deploy it as a role in, it runs on Windows Azure as a role. In database, you have relational database, SQL Azure. There are few features specific to data sync. You can sync your SQL Azure, multiple SQL Azure in cloud, or you can sync your SQL Azure running in Windows Azure and your on-premise SQL server. So that kind of synchronization you can do. You have reporting also available, SQL Azure reporting. For integration layer, we have service bus. So these service bus, access control, and caching, they are part of a common service, a common platform called Windows Azure App Fabric. So whenever I say Windows Azure App Fabric, it includes App Fabric caching, access control, and service bus. Then finally, marketplace. So you have to have a marketplace where you can sell, buy applications or data. So if you look at this platform, it has everything. I mean, right from your networking component to a place where you can buy and sell your applications. That is the richness of Windows Azure platform as such. And there are a lot of features, like as I said, integration. If you see connect, desktop, there is something which Microsoft is working on. Probably very soon we'll see something desktop kind of service available within Windows Azure platform. We have something called composite application. So very easy to add new features, very easy for developers or application developers to consume it quickly. So that is the richness of this Windows Azure platform. So as we talked about Windows Azure Compute, like we have web role, worker roles. Web role is used for. We are just going little deep into the features, and then we'll see a demo. So here, web role is nothing but designed for handling the web requests. Specifically, we can talk it like IIS server. So we can deploy ASP.NET, WCF. We can also deploy your CGI and PHP applications. Worker role, this is for arbitrary tasks, as we talked about. You can actually create a worker role which accepts HTTP or HTTPS requests. Mostly you would see for inter-role communication, you are using queue and worker roles processing some arbitrary tasks. You can also expose your worker role as the TCP ports. VM role, as we talked about, create a VHD and just run. In terms of storage, now we saw that in storage what features we are going to use, like tables, blobs, and queues and drives. But just to touch the point, scalable storage. So for one account, you see there are 100 terabytes per storage account. It is not a hard limit. If you want to extend it, you can talk to Microsoft and they can actually make use of extend it and probably can get more storage for it. It is auto scale to meet massive volume and throughput. It is storage infrastructure, the physical layer of storage is actually being managed by Windows Azure data center assets. You don't have to worry about where it is stored, how it is going to be stored. You just have to design your storage appropriately and it is going to be scaling automatically. And this storage are available, readily available over RESTful web services. That is the best part. So it kind of, you can access from anywhere via internet. So whenever you have an HTTP access, you can access it from your mobile phones, your smartphones, Windows tabs, and everywhere. So you can just consume that as a readily available RESTful services. Again, going a little bit into the storage part, the tables which we talked about, they are not relationals. So what it is? So it is a group of entities. And every entity is nothing but a name and value pair. And they are partitioned by key. So what it means is, so you have an entity which is self-contained entity, which has a name and value pair kind of structure, and you can scale it to billions of entities without actually, worrying about the performance of table storage. So very good storage for scalable applications. And blobs, large binary storage, they're actually stored in containers. For example, you want to store all your images in one folder. Containers are nothing but a folder kind of infrastructure, and that can be delivered through CDN to increase your media streaming and fast access to your contents, binary large objects. Messaging queue, yes, they are non-transactional, but they provide the idempotency, delete to remove message, otherwise return. So you access a message, but it is not deleted as against the normal standard practice of queue. So it is for idempotency. So if you process that message and if you see that the processing is not complete, it's not successful, just don't do anything. Next time you try to access the message after some time, you will actually get the message. So whenever the processing is complete, you can delete and say that yes, I have removed the message since processing is complete. And this is VHD type which we talked about, which is backed by a block. A specific point here is it can be written by only one instance, one request. Others can actually access it. Having said the context, let us see the demo, the real thing. And here I'm just going to talk about few prerequisites, and most of the time we are going to spend into our Azure Suite and the cloud, Windows Azure Platform. So prerequisites: you have to have Windows Azure SDK 1.6, which you can download. Just bring it and see MSG, and you can get it. I'm running an environment on Visual Studio 2010 SP1, and I have Windows Azure SDK 1.6. That is the prerequisite, and along with that, you see all the extension available for IIS and other things when you install Windows Azure SDK 1.6. We are going to create a new cloud project. We are going to run it in the Development Emulator. I mean, you can call it just Emulator. It is for emulating the environment of Windows Azure on your local machine. Then we'll see, we'll just get introduced to the Windows Azure portal. It is for as I talked about, self-servicing your cloud infrastructure. So that is where the portal is. Then we'll see another tool, free tool, Azure Storage Explorer. It is available on Portplex, which can be used to see your table content, table storage contents, or blobs or queue from your desktop. Then we'll do deployment of this application to Windows Azure, and we'll run it from Windows Azure. So having said that context, let us come here and see how to create an application. So I'm opening my Visual Studio. Now, a very important thing here. Whenever you start developing an application, if you are not an administrator, logged in as an administrator, run your Visual Studio in admin mode. Right click, start as an administrator. You should be in administrator mode always to start developing application in Windows, Visual Studio, because of the access which needs to run it in Emulator. While after installing your Windows Azure SDK, you will see a new project type. I said File, New Project. I'll get Cloud, and here it says Windows Azure Project. I select this project, and I'm just going to call it Demo to Cloud. This is the project type which I'm selecting here, and it is going to create a folder. It's a standard. Most of the things are very similar to the way we used to develop applications inside Visual Studio. So I click on OK after selecting this. So here, if you see, I'm getting the roles, readily available roles. So I can create ASP.NET web role, or I can create an ASP.NET MVC3 web role. Ultimately, all these web roles are going to run on IIS, and they call it web role. But for project template point of view, Microsoft has provided a specific templates for MVC3, MVC2, standard ASP.NET web role, or you want to create WCF kind of service, you get that readily available. Then we also have a Silverlight business application for VR services and a worker role, which I said, background processing services. For this demonstration, just to keep it simple, we are going to select ASP.NET web role. So I just select here. You can select multiple roles here in the same Windows Azure solution. We'll see that in the next part. But as of now, I'm just creating web role. You can actually add a worker role also. You can add one other MVC3 web role. So that all these web role will become part of the package. All these different roles will become part of the package. But every role is going to run in a separate instance. That is the important thing, which we'll see later. So here I just select web role and I give it name demo web role. Select it and okay. It's as good as creating a new project and selecting some project template from your Visual Studio templates. So here I selected the cloud project and I selected a web role, ASP.NET web role. It is just setting up an environment for me in the solution. So let us see if we are ready with that. Okay, so the project is ready. Now here, I'll just explain to you about the solution structure. If you look at it, this demo web role is nothing but it is our standard ASP.NET web application with some additional things. What are the additional things? So this is the web role.cs. You see this web role.cs. I'm just opening it here. So it has a class which is inheriting from a whole entry point, and that is where Windows Azure knows that this is a web role which I have to start, and that is where the infrastructure of web role is going to start. Otherwise, everything else like your references, your global.asx, master file, script, and everything else is as good as your standard ASP.NET application. So this is your web application, and this is a project which is nothing but actually a package which is going to tell Windows Azure, okay, I have these many roles, and this is how you have to run them. So this cloud project, I have one role here as of now, demo web role, which is nothing but this web application. If I had selected multiple roles here, like worker role or MVC3 or two web role for that matter, you would have seen these roles in here, the multiple roles. Now, service definition, look, this configuration file will see one by one. So before doing that, let us run it and see what it looks like in the development environment. So here, I just want to change the default to say hello world from Windows Azure. That's all I have to create the project. I just set up, change something, and here an important thing. This is this icon if you see after before running that application. This is compute emulator or storage emulator. This is nothing but emulator available for running Windows application. So I'm just clicking on show compute emulator, and here I'm going to see locally when I run the application, I'm going to see the instances, the service endpoint, and those kind of things, which is very close to what it is going to do in Windows Azure. So I run this application, and it is nothing but your cloud project. The cloud project should be a startup project here to make it run properly in your local environment, and emulator, development emulator. So I just clicked on F5, and very soon we are going to see a simple page which is like hello world from Windows Azure, and this is running inside this emulator. If you see here, this is my solution name, the cloud project. This is my web role, the demo web role, which is here, and this is number of instances. So as of now, I have said by default is picking up one instance, and that is why you see that one instance running here. This is nothing but some user interface for seeing that Windows Azure Compute emulator. Now it is setting up the emulator internally, and at the end of that you'll see a ready application running as a Windows Azure application running on a local emulator. Since it is running on local, it will have local endpoint like you would see 127.0.0, that is local host, and by default, since 80 is a code which it does not want to block, it intelligently picks up the next available code on the local machine. That is what your hello world from Windows Azure. This is the application. It is readily running from your emulator, which is a Windows Azure application, web application. Now, to make it more interesting, what we would do now is see the service definition file. So this is the file which is responsible for telling the Azure infrastructure what is the package, what this package is going to include. So here I just have a web role, so it is talking about only web role. Had I selected worker role, it would have another entry for worker role. So this is your definition. What are the services you need? That is the definition of this. And then you are using an endpoint, HTTP endpoint. You can make it HTTPS also, and add a certificate. You can change the port and etc. Now, service configuration. This is a file which is available after deployment. Also, you can change it. So there are two files here. By default, when you run in the local emulator, Visual Studio intelligently picks up the .local.csvg file, which is available for your local settings, and then you have a cloud.csvg, which you change and while deployment you have a settings, different settings for running in cloud, different settings in running for locally. Now let us talk about the storage part here. So for storage, just to give you just to introduce you with the storage part, we are going to log we're just going to enable logging in our web row, okay, on the web application. And all these logs by default, the diagnostic settings which we configure, we are going to get it into Azure tables. So just to do that, I already have an application, just to save our time. So this is the same application which we have here. What we are doing is we are just setting up diagnostics. So to set the diagnostics, I'm just saying start the diagnostic monitor configuration. I'm saying that I have to just transfer the logs. All the logs will be captured by the standard system.diagnostic.trace. Okay. In the web default page, I'm logging the system trace information. We are very used to this system.diagnostic.trace. The way it is transferring these logs to Windows Azure table is because of this web.config setting, which you see here. So we have added a listener for Microsoft Windows Azure Diagnostics Monitor Trace. Okay. So whatever we are logging to the trace, it is going to go to this listener, and this listener is responsible for adding your logs to the Windows Azure table. Okay. Now, if you come back here in web row, here we are saying that we have to use this connection string. This connection string is for Windows Azure table storage. Okay. And we are configuring this connection string in our service configuration file. So when I'm running in local, I'm saying use development storage. Okay. And when I run it in cloud, I'm saying use this account, specific account which I'll just explain to you. So I run this locally again, this application, and I should see this is the tool which I was talking about. Azure Storage Explorer. You can download it from Codeplexx, and you can just configure with any account you have. You can just click on account, and for example, if I click on account, you can enter the storage name, which will get it from Windows Azure portal, and the key which is required to access. If you want to use a developer storage, you can just check this box, and you'll get something like dev storage, which is a local storage emulator available for cloud. Now, if I see this logging, now I started the logging here, and whenever I access the page, same page, and if I keep accessing it, I should see some logs in my table. That is the intention. So this is the interface tool available for accessing the tables in Windows Azure. Similarly, you can just see blobs. You can create multiple blobs, files, and all those kind of things. So you can see here. Okay, a very good tool to use once you start development. Good tool to start with. So this is one specific point which I just wanted to touch base. Now the best part. We have a local application running on your machine. Now it's always good to see it running in cloud. So let us see that. So what I'm going to do here is, let us see how do I deploy it. Before deploying it, let us go and see Windows Azure portal. I have intentionally opened this portal in Chrome just to see that everything is fine. I mean, it's nothing to do with Internet Explorer. So you have to log into windowsazure.com. You have to just buy a subscription. If you want, you can see here. .com. Your ID is subscribe for getting the Windows Azure subscription. That's why I'm just directly getting this management portal. But in all the cases, once you buy the subscription, you come log in here and you get something like this. This is called as Windows Azure portal, management portal. So here you get all the getting started features, hosted services, storage account, and CDN. And this is a very specific part where we are going to create our hosted services. Hosted services is something like where you want to deploy your application to run. Like I can say web role, worker role, all these things, whatever is running, compute is actually hosted service. Storage account is like your table, storage, blob, and queue. Including all these things, you get one storage account, which is okay, let us see. For hosted services, I have one subscription, which I bought. Underneath that, I have created two hosted services like Sachin Demo, TechGeek Demo. Underneath this, as of now, there is no application deployed. For Sachin Demo, if you see, there is an application deployed, which is TechGeek Demo 1 Cloud, which is nothing but, if you see, it is running in an environment called as production. This is web role, and this is one instance. if I add, I'll show you how to add multiple instances. I mean, quickly have multiple instances. So for another hosted service here, I have a TechGig demo. So there is nothing deployed as of now. So there are 2 slots which my Windows Azure provides to us. Production deployment. So this is a real endpoint which you will get. For example, for Sachin demo, I have an endpoint called as sachindemo.cloudapp.net. You will see it here. So this is the name text thing which you can access the application. Everything has the domain name as cloudapp.net. In staging, what happens is Windows Azure automatically creates a GUID, and then every time when you deploy an application in staging, it is going to have a new GUID, GUID.cloudapp.net. Just to not make it available to other users to case and access your staging environment, because staging is something which you just want to run for some time, testing purpose, and then move it on to the production environment. That is the use of the staging environment. Apart from that, there is no difference. So you get charged equally on staging as well as production. Another advantage is you can run your deployment applications to staging. Once you are happy with that, you don't have to redeploy your application. You can just say promote it to production and you can stop the production and staging environment quickly. One of the best feature of cloud of other Windows Azure for testing purposes, application goes through the multiple cycles. You could create multiple environments and just create a staging environment, test it and quickly promote it to production. Now, so first of this, so I have 2 hosted service. So hosted service is nothing but where I'm going to deploy my application. It's a compute code. I can say here codes used. As of now, I have 2 hosted services, but only 1 application running. Okay, so charges are applicable at the time your application is running. Where even if it is stopped, still you are charged for it. Unless you delete, you are not consuming resources, you are not charged for it. Storage account, I have created 2, Sachin data, Sachin demo. Okay. So this is this storage account is actually a combination of Windows Azure table, queue, and block. So one storage account contains all these things. To access this, the name of the storage account is your name of the storage account, which you have to use this storage account, and then the primary key or second key. There are 2 keys which are available to access. So if I click on this primary key, so it will show me the primary key which I can use to access my account either from code, tools, or wherever. So currently when I'm using Windows Azure Storage Explorer, if you see this, I'm using Sachin demo my account. I can see it here running. And when I add account, I entered here Sachin demo and I copied that storage key, pasted here, so that I can see all the tables available, all the blobs available in my storage. Okay. This is the endpoint. So for blob, to access your blob through RESTful, remember on the presentation we said all these storage are accessible through RESTful web APIs. So that is your endpoint. Sachin demo.blob.core.windows.net. So you can actually consume your blobs, access it, upload it using the REST API. But every time you have to access it, you have to provide your name and this key becomes your as well as password to access this blobs, table, or queue. The 3 endpoints which they provide. So basically the account name is Sachin. 2 very important things here. The rest of things we'll see in the next sessions, but you can see quickly the databases. You have SQL database, you can create multiple databases. You have data sync feature here where you can configure to synchronize your SQL Azure with your local SQL server. Reporting services, you can create a new reports, and everything is accessible through an endpoint. HTTP mostly. Like service access control, we talked about these features. Virtual network is Azure Connect. All these features are readily available on this portal. All these features, whatever we are seeing on the portal, are also accessible through something called a Service Management API. So that if you want to write your application, you can actually write your application as well as your portal. You don't have to come to the portal all the time to do all the things. You can do everything, writing code, .NET code using Service Management API. Those are again RESTful APIs which you can consume and do all this, all the operations which you are doing on this portal. For example, if you want to create a new hosted service, so you can actually write a code, and there are PowerShell scripts are also readily available to create or to consume all these Service Management APIs. Codeplex is available. The only part here is the important part is management center. So whenever you are writing any Service Management APIs, as the name indicates, it is APIs available for managing your service Management APIs. all these calls require this management certificate. So in every request, you send this management certificate, and here it is ready, available. So you use that public and private key and make send the request, and Azure will actually respond to your request using this authentication mechanism of certification. So I hope we understand. Everybody's with me, and we understand this portal. Let us go back and try to deploy our application from Visual Studio. Here, I come back to my application. Let us do this. Now you have to select the cloud project, and there are two options. So let us see package. So when I say package, what happens here is, so you remember I have two configuration files, service configuration for cloud and local. So since I am planning to deploy it to cloud, I prefer to select cloud and just come back here. In cloud, I will have different settings which is specific to my cloud. Let's see here. For this demo, when I say cloud, I am actually using a storage diagnostic, like all the diagnostic logs should go to my account Sachin demo, which is available in Windows Azure, and this is the key, the primary key which we picked up from the portal. But if I run it on local, I don't want to store it into Azure storage. I want to store it in the local, my emulator. So that's why we keep this use development storage. This is kind of hard for it. If you put this, everything you will see in your local storage. So when I say package, it asks me which configuration you want to use. Obviously, if I'm thinking about deploying it to cloud, I am going to use the cloud configuration. Another feature which we will talk about it, enable remote desktop for all roles. Sometimes what happens is when we develop large applications, there are some issues where we want to really get access to the machine, virtual machine where the application is running. In that case, you can enable this remote desktop for all the roles, so you can log into that machine remotely over HTTP. We'll see that also. For that, it just asks, it uses a certificate internally. So you just have to create a new certificate, or Visual Studio provides you, helps you to create the certificate. So I'm saying here the username is this, and I know the password, which I'm not going to say here. So I have enabled a remote desktop, and I say package. So this is one way of doing it. So what we do here is, it is going to create, Visual Studio is going to create a package for us. So package has two files. CSPKG is actual package, which include all your binaries. And CSCFG, this is a file which is separate from package, and it actually contains all your settings. So these settings which you talked about. Like for example, it is as well as app settings your web.config file. So here I say setting name, demo config, local app. You can change it without redeploying the application in Windows Azure. We'll see that feature also. This is one packaging it. So if you package that, you come back here and say, new production deployment or new staging deployment. For example, I click on new staging deployment. Demo. And then package location, just browse locally and come to that location where Visual Studio has created our package. Click on browse, I come to my folder where Visual Studio has created a package, CSPKG file, and the configuration file is nothing but CSCFG file. So I select this. This is one way of selecting that. So as of now, I said new staging deployment. I select my browse. I select my package and configuration and say OK. It will deploy it here. I have not said OK. Cancel. Another way to deploy this is, if you come here and you say publish. So here it actually a wizard which helps you to deploy it automatically without going to your portal. So most of the time we get into this scenario. We're going to deploy multiple times. So why should we go to the portal every time? So Visual Studio has this wizards. So here you have to get this subscription files. Okay? I'll show you how to get this file. So whenever you have your Azure account ready, you can go to this endpoint. Once you have to go, download a file called a publish setting file, which includes service management related information. This is not insecure. This needs basic live authentication, the subscription authentication. Okay? After that only I'm going to get this file. You can see this. So that endpoint will give me a publish file which I have actually imported here, and then I don't have to enter my certificate details or subscription name as such. Then I say next. So it asks me which hosted service I want to deploy. So I said take gig demo. It is asking me which environment. you remember, we have two environments, production and staging. So I'm just going to save staging here, so that I'm just going to test it and then we'll release it. And service configuration is cloud, and build mode obviously release. Here I enable say remote desktop and I enter username, password, so that it is going to help me enable remote desktop on the cloud machines. And this is a very convenient way of deploying your Visual Studio application, your Azure applications to Windows Azure. I say publish. It is going to take some time, and then it takes 7 to 8 minutes. So I'm not going to wait till that. I'm just going to show you an application which I have already deployed to save time. So Sachin demo, this is the same application which I have deployed, and you can access it from here. This is a DNS name which is accessible over the cloud. If you see sachindemo.cloudapp.net, this is not running locally, it is running in cloud. You can run this URL on your machine and you can see the same application. So what it means is, we have developed an application, we have deployed to Azure, and it is readily accessible over the cloud. So if you type sachindemo.cloudapp.net, you should see something hello world from Azure. Very simple basic application. Conceptually, I think if you are with me, you should understand the flow. Login, if you remember, I was logging into this application. So if I was just setting a trace information, load. I want to see if it is generating the logs or not. So I go to add log table. I see this is the log which I get. Default page load. So it means my application is running fine and I'm getting this log. These logs are not immediately readily available. So what happens is there's a scheduled time which we have configured in the code. So Windows Azure transfers that log information every 1 minute. Here we have configured. Okay. So what the logs we are generating, that locally stored on their virtual machine and then transferred to the backlog table. So we have a readily running application on Windows Azure. To begin with, just wanted to set up the context before we go to the end of the session. Just want to show you a few quick things here. Now, as of now, if you see in this application, web role, I can see instance as only one instance. Now, imagine we are talking about readily available elastic scale self-service, all these terms we used. How do I make use of it? I select this and I say configure. So this configure is nothing but my service configuration file. Here instance count is 1. I'm just going to make it 3. I say okay. Increasing, it is going to increase the instance count from 1 to 3. What it means is, as of now, my application was running on only one web server. Now, since I said 3, within minutes, you will see the 3 instances, all load balanced automatically by Windows Azure Platform. I don't have to do anything, and it will actually have 3 instances running. So that, if I see my load increasing, I can increase it. And similarly, I can decrease it also by going to the same configuration. Remember, when this configuration is happening, my actually application should still run. So it does not impact my running of the application. Very smooth. And user will never come to know whether we have increased the or not. It is as good as the application was running on one server and you added 4 extra servers and they are load balanced. So if you imagine doing this physically, in your local environment, very difficult. Cloud, as we talked about all these characteristics, you can see it here. Now, very soon you should see, in 2 minutes or 3 minutes time, you should see we roll in 0, 1, 2, 3 instances running, and you can actually decrease it also. We'll come back to this management portal once again. But before we go there, just come back to the presentation. So we covered all this. Talked about prerequisites, we talked about Development Emulator, we talked about Windows Azure Portal, Storage Explorer, deploying Azure, running from Windows Azure. We also saw something increasing the instances using configuration, which we'll go back and see. Okay, so go back to the management portal, but before that, I just want to go to the service level agreement. So SLAs in Windows Azure Compute Connectivity, Microsoft says that it is roles will always have external connectivity greater than 99.95%. So your service will be reachable 99.95% times, very less downtime. So compute instances monitoring, again 99.9, mostly storage, SQL, Azure, App Fabric, such as all they have SLA of greater than 99.9%. You can go through the formal SLA available on Microsoft Windows Azure site and see, get into that agreement. Consumption prices, very interesting. As we say, it is no capex, it is OPEX, I mean operational cost. So we don't have to invest upfront. So it is all usage based. So if I'm using my small instance, we'll see that instance. So when you select a virtual machine, you have an option to say that I need a small version, or I need medium or large or extra large or extra small. So depending on the RAM and other things, we'll see where to configure that. And according to the charges change, like 12 cents per hour for small instance, for one instance. So when I say 3 instance, small instance, it means 36 cents per hour. That's how we can calculate it. Blobs and storage per GB 15 cents per month. So if I am storing 1 terabyte, accordingly they calculate per month. And all the transactions means accessing your blobs, tables, and what, like 10,000 transactions are charged like 1 cent. So very inexpensive assets. SQL Azure has multiple editions available. So it starts from 1 GB to 150 GB. So it's a kind of SKUs in terms of GB. So if I say I want to use 1 GB, I have to pay around $10 per month. So if I'm going to go to 10 GB, then around 99, irrespective of whether I consume 10 GB or not. But in Windows Azure Storage, I have to pay only for my consumption. So I don't go by a specific limit upfront. And then you have the messages and operations. Egress, it is called as outbound. So whenever you are getting the data outside Windows Azure Platform, irrespective of whether you are writing a code in your on-premise and downloading the data, or your web application is actually getting it outside the Windows Azure data center, it's charged at 15 cents per GB, and which is except Asia. For Asia, they are charging 45 cents. Earlier, Microsoft used to charge for the ingress traffic. I mean, when you upload the data to the Windows Azure, they used to charge for it. But now, recently, last month, I think they have made it free now. So it is no charges for uploading data to Windows Azure. For further details, you can go to windowsazure.com and pricing calculator. I'm just going to show you here, so that you can see how charges vary. Earlier, it was very difficult to figure out how many servers, how much I'm going to charge, and all those kind of things. There are a lot of pricing calculators available online. This is one of very quick and easy which you can quickly see upfront cost. So here I say I have small. If I say 4 instances, database, I'm saying okay, I need 100 GB of data. Blob storage, I think I will need like 5,000 GB because I'm going to store all my media files and everything. Bandwidth, generally it's difficult to gauge, but I'm just saying maximum say 1,000. I have a very heavy application. Now if I say I'm going to decrease the storage, you can see the cost here. I'm just going to change this block. Per month I'm just going to pay around $1,000, and I'm having 4 instances, very highly available applications. I can get huge throughput and highly available applications. For minimum thing, small 1 instance, you can just play around with it. For information, you can see windowsazure.com pricing calculator. I have shared that link at the end of the presentation also. So that is one part. And then, we were talking about this instance sizes. So there are 5 sizes which Microsoft provides, and I'll show you where to configure that. And these are the CPUs, memories, and I/O performance and pricing available. 4 cents per hour extra small instance, small 12 cents per hour. You have storage of 225 gigabytes and memory of 127. So maximum as of now you get is extra large, 8 cores, 14 GB of memory, and 96 per hour. So I/O performance is very high. Before you come back here, I'll show you where to configure that. Here, in your service definition, you have to say that you cannot change it as of now in the runtime, but the 1.6 SDK they have provided this feature. So here VM size is small, which means I'm going to get 12 cents per hour. If I want to just make it medium, I can just make it medium, package and deploy. If I want to make it large, just change it to large. VM which you get allocated for this size which you provide in service definition. Imagine in your local infrastructure, if you want to upgrade your RAM from 2 GB to 8 GB, everybody knows how much painful it is. Here it is just few words, type it, package it, deploy it, you get that much of readily available. That is what we're talking about, cloud. Now see here, so this application which I deployed from Visual Studio is getting deployed, but the one which I had increased instances to 3, it is still no, 0, 1, 2. I can still access this, and in case of predictable loads or unpredictable loads, as of now I manually did it, but you can write service management API calls, and there is something called the application block, enterprise library application block, which you can use to extend it automatically. And we have in Cumulus we have a product called Manage Access, which also one of the things which it does is to do this also. Anyways, so searching demo cloud.net. This is the application which I'm running. I just changed the instance. It is running in 3 instances. Very simple. Now, last part, I just wanted to show you the remote desktop. So if this is my virtual machine, you remember when I was deploying to Visual Studio, I enabled the remote desktop. I want to see something logging into the virtual machine. So I select this, connect. This is going to help me open, connect. Okay. Now, I'm trying to connect to machine, virtual machine, which is inside Microsoft data center, somewhere in Asia, because I selected the region in Asia. There are Asia, America region, then North America, Central America, then South America. Asia, you have multiple data. So you can select the data center where you want to deploy. When you create the hosted service or storage account, it doesn't matter where it is. I can log into this machine. You can see this. I'm inside this machine. The first instance, and here is my application. This we have root. Just because I know this, you can go to app root, and this is my default.asp, global.asp, and everything which I had deployed. Cool. Enjoying and following me. So that is how you can remote login. Generally, what happens in some of the cases where you are deploying, there are some version problems. There are certain words you think that you have to deploy old version in the package. You have to quickly go and check it out. So you can just remote desktop, enable the remote desktop in your package, log into that machine, look at it, see what are the DLLs available. If you want to change, you can copy and paste it also. Remember, remote desktop is a feature which is should be used only in staging kind of things. Then you think that just want to debug, test it out. Do not enable it for the production environment generally. Later on also you can, but you can keep it enabled, and then whenever you need, you can just go and see what is happening. So last part, and the best part. So here, if you see here, the application which I had deployed to Visual Studio, I had deployed it to staging environment. So here, you see the staging. Here it was in production. It is going to just get ready, and we'll see the endpoints. This is the endpoint. We talked about a GUID being used in that endpoint. So it is just starting the role. It generally takes 8 to 10 minutes to get that role ready. And once it is done, I can very easily say swap wipe. So here, when I say swap, it will actually get swapped to the production environment from the staging. So we'll see that also. Just click on here. Say okay. Very soon you should be having a different DNS name. It should be like take a demo, and you should be able to access it. It is like generally we used to have a staging environment in our local infrastructure. We used to test it, and then we used to copy everything again, repackage and deploy it to the production environment. In cloud, in Windows Azure, it's very easy. It's like a click of a button and you are good to go. Just want to end the presentation with the final slide where it says what are this opportunities to use Windows Azure, like the application migration and maintenance, data center extensions, where you want to just burst some of your compute to Windows Azure data center, new fresh application development where you think scalability or agility, mashup kind of applications. Some part of the application you want to run core engines, like for one of our customers, we actually it was e-commerce site, so everything else like data, customer data, everything was running on the on-premise. We actually got the e-commerce engine running on Azure. So that is kind of application extension. Storage as a service, very common scenario. You don't want to invest your capital in just having sandbox of 10 terabyte, but actually you are not using 10 terabyte, just using 1 terabyte. That kind of scenario you can use. Cloud is the best fit for that to begin. And best differentiators, which not because I am working on Windows Azure, but choice of primary development tools. I did not find much of a difference in developing application for cloud as compared to what I used to do earlier. very much, we have different kinds of storage like relational and table storage for scalability point of view. A lot of support features available for cloud hosted and hybrid solutions ready since it's Microsoft data center. I mean, good SLAs and good support and services. So it's enterprise ready. The target strategy. Windows Azure.com, a good place to start with. You'll get a lot of information there, like SDK download and all new happenings. You'll see in Windows Azure.com. Pricing calculator, as we talked about, if you want to just get a hang on how much you are going to spend if you want to run an application. And Storage Explorer, there are a lot of tools available. You can just bring Google and figure out what are the tools readily available, free tools available to see your storage. For SQL Azure, you don't have to get a tool. SQL Server 2008 R2, you can directly connect from your on-premise to a SQL Azure database, and you can see the tables and everything. But for tables and blobs, you might need some tools. So a lot of tools available, one of which I have been using for a long time is Azure Storage Explorer, which you can get from Cortex. Yes, you can see a lot of things we are working on, and Azure specifically, a lot of blogs, customers, scenarios, case studies. You can visit us at aditi.com. Thank you, and I'll go to the questions. Probably, moderator, please send me questions. I'm done from my side.
Okay, thanks. Questions are already shared with you.
Looks like hello. Okay, so I see some of the questions here. Okay. Yeah, so well, I'll try answering few of them since we have some 5-6 minutes. So what is the major difference in between data center and cloud? I think by the time we ended the presentation, you would have seen this. There is something called as private cloud also, which you can run in your data center. But cloud is something very debatable topic. But cloud where you have to go by the characteristics of what cloud provides. There's another question asked by Pawan Dhote. Can we have a desktop application deployed in the cloud? Yes, very much. So when you say desktop application, I'm assuming that it's not a web application. You have to access it, running double click and running an application. Not a best fit kind of scenario, but there are infrastructure as a service. You can create a VM role, deploy your application as part of the VM role, log in remotely to that application, that VM, and you can run it. So this kind of application virtualization. There's no other way to access it, right? So if you have a web application, somehow you're exposing your services web application. So I mean, nothing can stop you running it, but I don't know whether that would be a best fit to ask people to remote desktop into cloud and access it. There are a few things like Citrix is something which was used for application virtualization, so we can make that kind of things available. What is the difference between SaaS and PaaS? That's the next question asked by Asha. Okay. So probably if you remember that slide which I talked about, there's where SaaS and SaaS, you get an application readily available for consumption. You don't have a control on your application data. But in case of PaaS, you get readily available platform. Share that slide. So for application build development, and PaaS is the best suit. SaaS is a different game altogether. Like for example, you're using Gmail. You can think about it as SaaS, really not, but there is a question about somebody who's strongly opposing the cloud computing, is raising the false alarm regarding the information security threat. Information security is something, security is something which is evolving. Very important point I want to reiterate. I don't know about what people are talking about. As my personal view, I don't think everything will go in cloud. Okay? So there are scenarios, best fits of cloud, like the workload patterns we have talked about, like compliance and securities, which are not very strong assets. You can run those applications in cloud very easily. But some applications would never run in cloud. So never you want, when I say never run, I mean you don't want to deploy them in cloud. So we are not saying run everything in cloud. Like it is like we used to have two-wheelers, then we got four-wheeler, then we got railway, then we got local transport, then air transport. But still we have to make choices. Like sometimes we drive our car, sometimes we prefer to go by bike, sometimes it depends on the context and the situation. It is not that all the time you want to travel by only one medium. So that's what my opinion is. Is there any facility to learn the development of cloud application free of cost? Yes, just visit windowsazure.com. You will see a lot of materials available. Probably you will have a plan how you want to attend, go through it, but very good resources. Is there any connection between cloud computing and SAP? So SAP is an end product. Cloud computing is something to do with the infrastructure. So you can run SAP on cloud, but I think there is a service available SaaS through, they call it SAP as a service. So you can call it SaaS. So nothing much of a similarity which I can make. Okay, another interesting question, Syed Nazim. So can we create a cloud project other than C#? Yes, you can do that. If you don't need, you can do it. Java, Windows Azure. Can we add existing ASP.NET application in cloud application? Chandran, that question. Very small changes you have to make, like states, storage, and other things where we use on Windows Azure. I think it's no big deal. Azure SDK compatible with Vista? Yes, it is. Let's imagine ask that question. How to install database on cloud? How our applications talk to database? Chandran Kumar asked that question. I'm assuming when you say database, I'm assuming it is SQL Azure database. So in next session in the series, we'll talk about that also. But it is as good as as we created the new storage or hosted service, we can create a new SQL Azure database. Run your scripts to initialize that database and you can access it from your application as good as you are accessing your on-premise application. Similar kind of connections too. Small differences in terms of the server name and TCP colon server name and the username. But technically, not much of the difference. Okay. Another interesting question. Srinivas asked that question. By developing our apps on Azure, the benefits seem to be many. However, do we get logged into Azure platform, or are the applications portable to other tasks as related question in the cloud, or is there any role set? Okay, a very interesting question. I actually wrote a blog on this, but I just want to quickly answer this. So when we're talking about locking, my personal opinion is, as long as you're talking about standardization of VM, it is okay, because but ultimately, the locking has been there for so long. When we used to run application on Oracle, it was not very compatible with SQL. We had to make changes and run it on SQL. That is one platform. For example, developing application for Linux, not sure how quickly you can just run it on Windows. Like Java applications. When you develop a Java application, you're actually getting locked to Java, right? So you cannot run them on .NET. So point is, I don't know where you have to draw a line. Where do we see that locking happening? Another part, probably, in one of the cases where we initial stages when customer had this doubt, we developed a portable library where you can run the same application on Azure, obviously in .NET platform and ASP.NET and IIS, but you can also run local IIS and you have local SQL. So we have that abstraction of storage layer and APIs. Kind of. Another question. Cloud is dependent on internet, and the situation in India is poor for internet speed. How do we see cloud will work for India? 4 or 5 years probably before, if somebody would have said, mobile is something which is only available to specific people. 6 years back, I remember 2001, 2002, it was like incoming calls charged 12 rupees. You could never imagine that any a common user will ever get access to mobile. Now you you see the difference. And similarly, looking at the infrastructure which is growing, the mobile and connectivity, I think well, we should be we should be positive or optimistic at least about getting that infrastructure readily available. Just a question though. Okay, another question. I think I'll just okay. So I'm going to take the last question probably. Please tell about the investment to start. Interesting question. So upfront, I think we should not invest into something like running an application on Windows. You can buy the subscription, keep it with you. It needs a credit card or debit card. Buy that. Don't use it personally. Start running your application locally, try it out, play around it, and when you think you are okay with running that, you can run it on Azure and pay for only the consumption which you are doing. Very important thing: do not forget to delete your application if you are testing it, and don't run it for time when you don't want to use it, because it is charged by clock hours. Even if I'm not using my application, it's deployed there. So it is as well as I'm consuming that resources. So I'm going to pay 12 cents or whatever. So please make sure whenever you are not using it, delete that deployment from there. Storage you can keep it. It's very cheap, 15 cents. I think most of the questions I answered. I skipped few of them, but yeah, I think good to go. So thank you very much, and look forward to see you again on this series of cloud. And thank you very much. Thanks, TechGeek, for giving me this opportunity of talking here. Over to moderator.
Thanks, Mr. Sachin, for your informative session on hands-on Windows Azure and building deploying end-to-end applications. It was indeed an enlightening session. I would also like to thank our participants for their support in making this webinar a huge success. The recording of this webinar will be available on techgeek.com by tomorrow. Gentlemen, the next session in Cloud Computing series is happening this Thursday, that is 12th January at 3 p.m. Topic for the session will be Deploying Models and Service Models in Cloud Computing. We'll be having Mr. Rohit Goyal, Consultant Microsoft, as our guest speaker. So see you all on Thursday. Thank you.